Welcome and thank you for joining my talk. My name is Adriano Luceri. I'm PhD researcher at the German Research Center for Artificial Intelligence, short DFKI, where I focus my studies on the development of explainable AI systems for the use in medical imaging. In the next 8 minutes, I will introduce you to a part of my research called exAID, which is short for Explainable AI in Dermatology. But first, let's start with a quick introduction to skin cancer for those who are not familiar. Malignant melanoma is a type of skin cancer that is caused partly by genetic predisposition and through excessive exposure of skin regions to UV radiation. With over 20,000 incidences only in Germany, it is responsible for around 3,000 deaths per year, which amounts to a mortality rate of around 12%. A patient's chance of recovery are quite high in early stages, but as the cancer reaches deeper layers of the skin, chances decrease. This is also why melanoma is often considered the most dangerous of all skin cancers, and the asymptomatic nature of the disease makes it so insidious. Also, distinguishing between a growing melanoma from a benign nevus requires an experienced eye. So from this, I think it is clear that early detection of melanoma in patients is crucial. At present, dermatologists manually diagnose skin cancer by inspecting each and every skin lesion on a patient, searching for disease-indicating criteria such as structural or coloral patterns. They usually use magnifying devices to visualize deeper skin layers. Although they obtain high detection rates, their specialization requires extensive training and experience, which led to a lack of specialists all over the world. This process is also very laborious and subjective. Now let's say we add an artificial intelligent decision support to the examination. We will keep or might even slightly increase the detection rates, and the decision aid will increase practitioners' efficiency, thus increasing the availability and quality of services for patients. However, there are still valid concerns about using such opaque systems in high-stakes decision-making. If we really want to support doctors, we must augment them with systems that suggest decisions, but most importantly, point out their reasons. This form of transparent decision-making will also gain trust of doctors and finally of patients. This is exactly the goal of our exAID framework. exAID is part of my research work at DFKI and is based on state-of-the-art concept-based explanation methods that allow to explain any given deep learning model after training. The system can currently showcase two scenarios. The diagnostic mode is meant to augment practitioners by providing textual and conceptual explanations along with concept localizations. The analytic mode enables AI developers and medical researchers to analyze concept influences and the collected medical image data on a global scale. This helps in model debiasing, disease criteria discovery, and in supporting the training of prospective dermatologists. And the best is that exAID uses expert-defined disease criteria as concepts that are understandable for practitioners. Let's quickly have a look at the explanation procedure. At first, we train a deep neural network using some training data to diagnose a disease. Once trained, we define domain concepts together with experts from that domain and let them annotate a small amount of image examples. The exAID framework now wraps around the trained deep learning classifier and uses the annotated concept data to translate the representations used by the network into those human understandable ones. This allows exAID to predict independent concepts and to also localize them. Enough talking, let's have a look at the interface. First, let's start with the diagnostic mode. This is the interface which is provided to the dermatologist. He can now select the current patient and then choose one of the captured images. The AI processes the image and exAID provides explanations. The first level of explanation is given in the top left corner, containing the textual diagnosis with information about concept indications. The second, more detailed explanation consists of detailed concept scores that reflect the degree to which a concept has been detected in the image. If a practitioner now is interested in the exact location where the network detected a disease criteria, he can simply click on the concept score and adjust the transparency of the displayed heat map to his liking. Remaining information, like the network's differential diagnosis and further metadata, are presented as well. The analytic mode of exAID provides a more data-centered view targeting AI developers, medical researchers, and doctors in training. The medical image data collected over time can now be used to detect biases in the network or even analyze interesting patterns in the disease. Most importantly, in the top left corner, we can see the global concept scores that indicate how the presence of a specific concept influences the network's decision for a given class. This dashboard provides additional functionality like a data distribution plot that is broken down into disease and concepts, a confusion matrix showing the network's class confusions, as well as a plot of performance metrics indicating how well the network performed on the given dataset. On the bottom, we have a selector that allows to switch between different concept representation layers within the network, and on top we have a variety of options for filtering, sorting, and highlighting that allow to, for instance, filter a specific group of people by their sex, age, and lesion location. And here we also immediately see which concept has been classified correctly by the network, indicated by the red and green icons. Note that the data distribution and confusion metrics adapt to the filter options. Lastly, we can also activate the heat map overlays in this overview mode. At the end of the day, our goal is to help people and prevent lethal diseases. We think that a successful application of AI in clinical environments requires an iterative and sequential approach. Given AI and a lot of data, developers and researchers first need to open the black box and understand the decision-making processes. This allows us to improve not only their abilities and robustness, but also to improve our data pre-processing and might already lead to new insights about the data. This combination will also finally enable AI to gain the trust of domain experts and patients. Only once this foundation is given, it is ready to be applied in clinical environments and serve its purpose to minimize the mortality of patients by augmenting human experts. With exAID, we aim at providing a system that allows to run through this iterative process in just one application. The analytic mode allows to systematically study failure modes of the AI and identify new medical key concepts. This can be used to improve the deep learning models, which will gain the experts' trust. exAID is designed to be ready for application in clinical trials and therefore covers the whole process. The framework is currently under development and will obtain more functions and explanation modalities over time to finally offer broad and diverse explanations. Please note that dermatology is just the first application area of our framework, but provided enough data and expert knowledge, the methods adapt to any other medical imaging domain. I hope that you could gain some insights into our team's work, and I would really appreciate if you visit our project page. An online demo of exAID will also be available in the near future. If you're interested in the methods used, feel free to have a look at our publications related to exAID. Thank you for listening, and don't hesitate to ask questions.